Okay, let's just state it plainly. The system that powers our entire modern world, our energy grid, is running on an obsolete operating system. Seriously, it's inefficient, it's unfair, and frankly, it's holding us all back. But what if we could just scrap it and redesign it from the ground up, using first principles? Well, that's exactly what we're going to dive into.
Right, let's start with this chart because it shows the sheer scale of the problem so clearly. What you're looking at here is a plot of a country's energy demand versus the number of people it takes to run its energy system. You can see this really obvious trend line where most countries, they cluster together. And then just look at the UK. All the way up here, a massive glaring outlier. We have this huge administrative machine for the amount of energy we actually use. It is genuinely staggering how bureaucratic and unproductive our system is compared to everyone else.
And look, this isn't just some academic theory. This sharp diagnosis comes straight from Greg Jackson, the CEO of Octopus Energy, one of the biggest names in the industry. The message couldn't be clearer. If you want to be a world leader, you have to be efficient and innovative, not bloated and slow. And right now, we are painfully far from that goal.
And we need to be really clear. This isn't just about numbers on a spreadsheet. This inefficiency has devastating, real-world consequences. We're talking about vast amounts of money just wasted. Costs that are unfairly passed down to you and me. It means people, tragically, can't afford the very electricity they need to live. It chokes the innovation we desperately need to solve our problems. And maybe the most dangerous part, it completely erodes public trust, which puts our democratic goals at risk.
So, the obvious question is, how on earth did we get into this mess? Because if we're going to fix the system, we first have to understand exactly why it's broken. And the roots of this problem, well, they go back decades.
At its heart, the issue is this. Our energy market was designed for a world that had a few big, predictable power plants. But that world is gone. Renewables came along, people started putting solar panels on their roofs and buying electric cars, and instead of redesigning the market from the ground up, we just kept patching the old system with these quick fixes, what the source material perfectly calls sticky plasters. And these sticky plasters are everywhere. We treat wind farms, which have a totally different cost structure, as if they're old coal plants. We've bolted on these complex capacity payments, which basically means we're paying generators just to be on standby. We use these convoluted contracts for differences to guarantee a price for renewables, shielding them from the very market they operate in. And then, on top of all that, we built entirely separate, expensive markets just for flexibility. Each patch just adds another layer of complexity and, you guessed it, cost.
This slide just illustrates the mismatch perfectly. The old grid was simple, right? A few big, controllable power plants sent electricity one way down the line to passive consumers like us. But today's grid? It's a completely different beast. We've got variable renewables like wind and solar, we've got active consumers who generate their own power and charge their EVs, and we have a two-way flow of both energy and data. The physics have totally changed, but the economics? They're stuck in the past.
So how do we fix it? Well, it is not about finding one more sticky plaster. This is a fundamental design challenge. We have to create a whole new system that can successfully balance three powerful and often competing forces.
Now, I know this diagram looks a little complex, but it really boils down to three key questions. Any market design that's going to work has to solve for these three axes you see here. First, along this axis, how do the generators get their costs back? Second, on this one, how is the actual price of energy decided? And third, this last axis, what assumptions are we making about people, about society who actually use the system? If you get even one of these wrong, the whole thing just falls apart.
Let's break that down into three hard constraints. Number one, people. The system has to be seen as fair, trustworthy, and something normal people can understand. Number two, economics. It has to be super efficient, no waste, and it has to let generators make money without a bunch of hidden subsidies. And number three, and this is a big one, physics. At the end of the day, electrons don't care about money. The system has to be physically possible for operators to manage safely. You have to solve for all three at the same time.
Okay, let's get into the solution. And this is where it gets really clever. The biggest change we need to make, the one that really unlocks everything else, is how we think about the price of power. It requires a completely new philosophy.
See, the old system was built on these flawed assumptions from classical economics, that everyone is the same, that we all have perfect information about everything all the time, and that we always act like perfectly rational robots to save a few pennies. The new approach starts from, reality. Society is diverse, people are busy, we don't have perfect information, and our reasons for doing things are complicated.
Accepting this changes everything. For decades, this is how we've priced electricity. It's called the single marginal price. And here's how it works. The price for all electricity is set by the cost of the last and most expensive power plant needed to meet demand in that moment. Now think about that for a second. If cheap wind power is meeting 99% of our needs, but we have to fire up one expensive gas plant for that last 1%, everybody gets paid that super high gas price, including the wind farm. It's a system that guarantees huge profits for some and high costs for the rest of us. Okay, so here it is. This is the central aha moment, the magic trick of this whole proposal. What if we just decouple the fixed costs, building the power plant, from the minute-by-minute price of energy? We find another way for generators to get paid for those big investments. This frees up the energy price to do something much, much more useful. To signal the real-time value of that energy to the grid, right here, right now.
And the tool to do this is called an automatic market maker, or AMM. So forget about how much a generator costs to run. The AMM is an algorithm that sets the price purely on the value of that energy to the system in that instant. It's less like a traditional market and more like a smart traffic controller for electricity. Its only job is to get wanted energy to where it needs to go as efficiently as possible, using price as its signal.
And this chart shows you just how elegantly simple it is. Look at this curve. When there's plenty of power to go around, the price is zero, maybe even negative. But as the shortage starts to happen, as we move up the curve to the right, the price rises exponentially. This creates this incredibly powerful natural incentive for flexibility. That super steep price is a massive, unmissable signal for batteries to discharge, or for your smart EV charger to pause for a bit, helping balance the grid almost automatically.
So what does this all add up to? What's the payoff? Well, by going all the way back to first principles and redesigning the market around these new ideas, we actually get a system that is fundamentally fairer and a whole lot smarter. The benefits here are just enormous. First, the price finally reflects the true value of energy, not some random generator's historical cost. It maximizes social welfare because it gives people real choice, letting them decide what's valuable to them. It automatically encourages all of us to do helpful things, like charging our EV when power is cheap and plentiful without anyone forcing us. And it creates a truly competitive market, where you succeed based on the value you deliver. The end result is a system that's fair, transparent, and just plain efficient. At the end of the day, our energy grid was built for a world that has simply vanished. Rethinking it from the ground up shows a path to a future that's cleaner, fairer, and smarter. And it leaves us with one final big question. What other critical systems in our lives are still running on outdated rules, just waiting for someone to come along and start over from scratch?